Hey everybody, good to see you. Hopefully today's going smoothly and you're getting ready for tomorrow's test. What I've got here is an old test and I'm going to go through every single problem. Hopefully we can all see everything okay and I will talk through every step. So let's go ahead and get started. So in these first few problems that you can see up here, you can see that they've got a number of different numbers listed. And while it might be kind of hard to see, you can follow along with this video. You could switch over and look at the test that I've shared with you that has all of these questions larger so that you can follow everything. So up here in the corner on this little list are the lists of the types of numbers that we've talked about. So there's imaginary, there's integers, there's irrationals, rationals, real numbers, and whole numbers. These capital letters next to them are what they are technically abbreviated to. We didn't talk about that this year. You can see that this was done in 2014, so something we talked about a while ago, but we didn't talk about this year. So we're going to go through and label each of these numbers appropriately. So I'll hit play here on my screen. So you can see that for number -8, it's an integer, it's rational, and it's real. Those are the three categories it falls under. For the square root of 200, it's irrational. We can't do the square root of 200, so it's irrational and real. Now you can see I've started to start writing more for the number 60. It's an integer, it's rational, it's real, and it's a whole number. So moving on, I went straight down here. That was an easy one. That's imaginary. For this, it's real and it's rational. It does end, so you can make that into a fraction. The last number here is real and rational. Those are the only things that you can do with that fraction. Moving on. This next part, what operations does a commutative property and associative property not work for? Subtraction and division. They do not work. All right, now getting in on some substitution of values. So you're going to see I put 20 in for D, and then 4 goes in for B. And then on the inside, I went ahead and I did a step right away. So right when I wrote this in here, you can see that I've got -100, and that's from doing the A, which is -5, times the D, which is 20, AD, so -5 times 20 is -100. And here where it says BC, that's 4 times -9, so that's why I got -36. So I'm going to combine -100 and -36 to get -136. But since that's in an absolute value, that's going to be a positive 136. Oops, let's get that going. Sorry if I messed that up. Goes. And you can see that the 136 is now positive, but it's being multiplied by 4. And 4 times 136, I worked out, took me a couple seconds, it's 544. So then 20 minus 544 is going to be -524. Moving on to this problem where I'm going to do some substitution. I've got some stuff to do in the numerator of that fraction. So I've got -5 plus 9, because minus a negative is positive, over 4, plus 20. And again, it's plus 20 because a negative and a negative makes positive. Now at the end, plus 20 minus 20 cancels, and I'm just left with a 1. Now before I tried to move on, -5 plus 9 is 4. 4 divided by 4 is 1. So this part becomes 1. 1 plus that is 1. All right, now the next part says simplify. So I'm going to be combining some like terms here. So I'm circling my c squareds, and I wrote down how many total c squareds that would be, -4. Then I'm going to box in my c's, and you can see that it's going to be a positive 11c. And then I just underline the constant part, just the numbers, and that's what we get there. Moving over to the next part, before we can simplify anything, we need to first do some distributing. And notice when you distribute 7m to another m, that makes 7m squared. And you can see I kind of went quickly through the rest of that. Make sure you distribute a negative sign to both of those parts. And there at the end, you can see that I've written the rest. Okay, so I circled the m squareds. Ooh, that's kind of hard to see. 3m squared there. Boxed in the m's, and I got positive 19m. And then at the end, just those constant parts are going to be plus 17. All right, now rearranging formulas. This one, pretty easy. We've talked about this one a number of times. To get r by itself, divide by t, you get r equals d over t. A little bit trickier here because we want to get the a by itself. So first I'm going to subtract the mc. And now I've got e minus mc equals the ap. Divide by p. And you're going to have a by itself. So a equals the e minus mc all over p. So now we can move on to the second page. On the second page, there we go. Let's zoom in. Great. And before I can solve this problem, as a reminder, we've got to do all of the distributing before I can do anything else. So that's a good rule of thumb for any solving of an equation. You're always going to want to distribute first. So you can see I've just started to do that there and there, there and there, there and there. And now I'm going to write it all out. Hopefully there's no mistakes. I didn't check this for mistakes, so you let me know if there are any. Talk to your classmates if you feel like you come across them. So now I'm going to put my a's together over here, and that's how I got negative 4a. I put my 5 and 18, my negative 5 and 18, that's how I got plus 13. And over here I put negative 3 and negative 2 to get negative 5. You can see I'm adding 6a to both sides to get my a's together, and at the same time I'm subtracting 13 to get them to the other side, and that's how I've got 2a equals negative 18. Final step, divide by 2 on both sides, you'll get a equals negative 9. On the other side, you can see here that I've got minus 9.4 on both sides. That's going to get the decimal parts all together, and it actually gets rid of all of your decimals at the same time, so we don't have to worry about multiplying out by 10. Now, we need to get rid of this fraction, so I'm going to multiply both sides by the lowest common denominator, which happens to be 12. So I'll have 4w minus 8 equals 60. Let's go ahead and add this 8 to both sides. So you have 4w equals 68. Last step, divide both sides by 4. You'll get w isolated, which is what we want, and you'll get 17 on the other side. Now the next one, the most intimidating looking problem on the whole test here. This one looks pretty nuts. Now, I agree that I think this one's probably too hard unless something unique and weird happens. Hint, hint, something unique and weird kind of happens in this problem. So, just like last time, we need to go ahead and distribute. And yes, I agree with you. These fractions look annoying and scary, but we can't get rid of them until later because you have to get rid of the parentheses first. Now, this is me just showing what I did after distributing. So 4/5 times that first part, that's pretty standard. And then on the other side, I've multiplied by 6. And so the 6 and the 3 cancel diagonally, and you'd be left with 4. And then in the other part, the 6 and the 5 couldn't cancel, so that's why it's 6/5. Now, what am I circling here? Oh, I'm circling some like terms to combine. Because on this side, I've got x's here and x's here, so I want to put those together. But I do want to point something out. If you wanted to get rid of all of the fractions right now, we could. We would have to multiply by the lowest common denominator. So let's look at our denominators. 5, 5, 7, 8, and 5. So the common denominator for this, the only way to get a common denominator with 5, 7, and 8 is to use 280. That's the lowest common denominator. I don't think any of us really want to multiply everything by 280. That's what makes this problem too hard for a test. But wait a minute. I've got something circled here. Before we start thinking about how hard this one is and if it would work on a test, 2x minus 6/5 x, which is really 1 1/5. So if we're doing 2 minus 1 1/5, what would that leave us with? 4/5. Now notice, that would be 4/5 x on the right-hand side and 4/5 x on the left-hand side. I actually don't care about this part. I also don't care about this part because our priority needs to be getting our x's together. And if I want to get the x's together, I'm going to subtract 4/5 x. Do you see what's about to happen? 4/5 x cancels, 4/5 x cancels. What do we have left? Well, from over here, I've got negative 4/5 plus 3/7. Who knows what that is? Something. And then on the other side, I've got negative 7/8 plus 4. We have no more fractions left. It might be kind of hard to see because the screen got really bright. But there's no more x's. There's no more variables left. All I've got are these fractions. And even if we actually don't need to add them together because I can tell that what's over here on the left and what this is going to add to with the positive 4, that's not going to be the same on both sides. So do these two sides equal each other? There's an answer to that question, and the answer is no. And that's the beginning of our answer, no solution. So that is a possibility that you could have happen on tomorrow's test. Now this last problem is a word problem. And again, there's a lot of words here. It's a long word problem that you do have to read. But I'm going to go through it and kind of just pick out the highlights. Okay, so I'm going to step over here, and I'm just going to read. Oh, the lighting just got way better with me stepping over here. Can't see me as well, but the lighting's better. Oh well, sorry. Should have done that earlier. I'm not going to refilm the whole thing at this point. Okay, so let's read about this. So Emily created a thing. She calls it an M reader, like a Kindle, a little different than a Kindle, it looks like, but whatever, that's what we're talking about here. She's going to spend $36,000 on research and development, okay, so that's money she's spending. She's also going to spend $12,000 on marketing, meaning advertising, so that's more money she's spending. So right away, if I put those two together, $36,000 and $12,000, she's spending $48,000 just on research and development and marketing. So that's the first thing we need to write down, is that she's spending $48,000 just to get it off the ground. So you can see here I'm writing $48,000, and then that's dollars really, but I didn't put dollars in. Is she spending any money in the rest of this problem? Well, let's see. It will cost her, aka she's spending money, $9 to make each M reader. So look at how I represent that in this equation. So 48,000, that was from research and development marketing, plus 9E, meaning $9 per e-reader, 9E. Now I've got equals because in the last two words of this whole thing, it says break even. So breaking even, we said, is when your cost, what she spends, equals the money she makes. Does it say in here how much she makes? She's planning to sell each M reader for $129. So the other side should be $129 per e-reader, which is E. So now this is just an equation for us to solve. Subtract 9E on both sides, the 9E's cancel. We get 48,000 equals 120E. Let's divide both sides by 120. One of these zeros will cancel out with this zero. 48 divided by 12 is 4. And there's two zeros left, so 400. And these things were called M readers. So 400 M readers. And there is an extra credit question, but I'm not going to do it today, and I'll let you figure out later why I didn't do it today. Have a good afternoon. See you later.